All right, now we're going to go into the EOS software, so that's EOS print. So you're going to get an error just because the machine isn't currently connected to the computer, and there'll be a separate video for that. So to load your part, you're going to go here to load part, and then we saved our stuff in TurboRing, so you're going to upload or import these two parts. Okay, so these are the parts that we made using Magics, or that we positioned, and these are the supports we made in Magic. So you can see how the part is imported in the same position and orientation as it was saved in the Magic software. So down here is your machine type. You can see that we're connected to the EOS M290, and then here is your material set. We're going to use Inconel 718. If you're going to use something else, this is where you would choose your material. But we're using Inconel 718, so we're going to click on that. And then placement, we don't want to do anything with placement because we already positioned our part how we want. You can move the part here, you can multiply it, but we're not going to do any of that. You can segment, you can do segmentation on the part, which means that you can cut it, for example, in half. And then the reason you would do that is if you're gonna use different parameters for the top half than the bottom half. We're not gonna do that. So in the exposure tab, this is where you're gonna do most of your work. For us, the parts, you can either use the EOS direct part, which is the parameters that EOS provides, and also the EOS support parameters. And both of these are EOS parameters, and you can see that they're locked, so you can't really see which parameters they use. And we don't want that. We want to change that, so we're going to do this profile for the part, direct part, and for the support, we're going to use this profile. And then you can see that these aren't locked, so you can go into, for example, the direct part file, and then here you can see all the stuff that you can change. You can change the layer thickness, you can change the hatch rotation, the infill. Here in the infill, that's where you can change like the laser power, the laser speed, and all of this stuff is just going to depend on your part and the material that you're using. I recommend you read some research papers on what type of settings other people have used for your material, because it's going to differ based on geometry and also based on material. Here in the process settings, you can change different things like the build platform temperature. You can see that the default value for Inconel is 80 degrees Celsius, but you can change that depending on what you want. For ours, I think we're gonna do like 160. You can also change the recoding speed. This changes the speed of the recoder. If you go too fast, the spreading of the powder might not be too good, so I'm going to change that to 80. And then I'm just going to leave this as is. For the exposure settings, you can define different things, and if you hover over the setting, you can see that there's a help pop-up that defines what that particular setting does. For example, configure first layers deals with the first layers that are deposited and scanned. So right now it's saying that the first 0.04 millimeters of your part are going to be defined by this. So strong platform connection means that the laser is going to scan twice for that first 0.04 to ensure that the part gets connected to the substrate. You can turn that off or you can turn that on, just depends on your part. 300% dosing means that the first 0.04 millimeters, the machine's gonna provide more powder than needed, 300% more, just to ensure that all the whole build plate is covered with powder. So I'm gonna leave that as is. And there's other settings here that you can change, but I don't think I'm gonna change any of that. Usually I just change stuff in the exposure set library and the process setting, but you could change other stuff if your project requires. In preview, you can go to build time just to check how long a part like this would take. Typically you don't have to leave this at 100%. Usually at 10%, it gives you a pretty accurate total time, building time. So in this case, the part is probably going to take like 60 hours of printing. That's a lot of time. So you want to make sure that you have enough argon that's going to last you those 60 hours. So at 10%, it says 58 hours, and that's pretty accurate. Once you have all your exposure settings done, like the infill, the upscan, the downscan. Again, if you hover over some of this stuff, it tells you what that particular setting does. So I would encourage you to go in here and take note of all this stuff. Like for example, for this part, you can see how the hatch, the contour, and then edge are numbered. That means that the part is gonna first do the hatch, it's gonna do the infill, the upskin, the downskin, then it's gonna move on to contour, do another contour, and then do the edge. You can change this, you can add another, for example, core, edge, hatch. You can change all that stuff just depending on your project. And you can move, for example, if you wanted to do the contour first, you can move the hatch down, you can move it up. It just depends on your project. You can change the layer thickness up here. if you move this bar up and down, you can see the particular scanning pattern that's going to happen at that intersection. So you can see how these green vectors are where the laser is going to scan, and then the blue contour is the contour that we saw defined in the parameters, this one. The green part is the infill. You can see how if we change the infill to, let's say we want a chest pattern, we do chest, and then let's say I want a square width of 5 millimeters, and then we save this, apply. You can now see how a square checkerboard pattern arises in this this simulation. So when you're changing parameters, it's a good idea to check how those parameters affect the scanning pattern, because the scanning pattern has a large effect on the residual stress, or just if you want to make sure that what you're changing is actually being changed in the settings, you can check that by moving this up and down. And once you have your part, it's a good idea to save this project. So I'm going to save this as turbo ring EOS file. And once it's saved, you want to export the part, but there will be a different video for that because you have to connect the machine first.